Alright kids, so we're working on Algebra Unit 2 exam. Unit 2, I think that's chapters, 3, 4, and 5? Okay, so question 1, it says, what is incorrect about each linear equation? So this equation is incorrect because this has a slope of negative 1 over 2, and the slope over here is actually 1 over 2. So we say this is the wrong slope. The y-intercept is legit, it's 2. So the correct equation is y is equal to 1 over 2x, and it's plus 2. Okay. For this problem, what is wrong with this? The y-intercept of negative 2, that's legit. It looks like the slope of negative 1, that's positive 1. So once again, this is the wrong slope. And the correct equation is y is equal to minus x minus 2. This one seems legit. It's a negative slope. There's a negative slope. But this one's a slope of down 1, 2 to the right. So the correct equation is y is equal to negative 1 over 2x. And that's it. Plus 0 if you want. So once again, this is a wrong slope. And then this looks like it has the y-intercept of positive 2, the slope of 1 over 2, so the slope is right, but it's the wrong y-intercept. Y-intercept. And the correct solution should be y is equal to 1 over 2x plus 2. That's a correct equation. Okay, part 2. Graph each of the following linear inequalities. So here's inequality, and I don't know how to graph this until I put in slope-intercept form. So maybe add x to both sides. So I have x plus 6 is less than or equal to 3y, and then divide by 3, and then I have 1/3 x plus 2 is less than or equal to y. And this means y is greater than or equal to 1 over 3x plus 2. So to graph this, I start the y-intercept of 2, that's over here. Slope of 1 over 3, so up 1, 3 to the right, up 1, 3 to the right, down 1, 3 to the left, down 1, 3 to the left. It's greater than or equal to, so the equal to tells me that it's a solid line, and greater than is above. So it looks like it's our set of points that's on top. Let's try. Do you have a highlighter? Oh, good. Thank you. So I'm going to highlight. I'm going to highlight the top part. It's so hard to use. There we go. Our set of points that's above that line. Okay, so to graph this one, I want to get the y by itself, so I'm going to add x to both sides. And I'm going to divide 3 by 2. Then I have 1 over 2x plus 2 is greater than or equal to y. This means that y is less than or equal to 1 over 2x plus 2. Y-intercept of 2, up 1, 2 to the right, up 1, 2 to the right, down 1, 2 to the left. It's an equal to, so it's a solid line. And it's less than. So less than is our set of points that is below this line. And there's my fancy graph. Okay. Get y by itself. I'm going to add x to both sides. So get the y on the other side, that's less than, switch to greater than, x plus 5. Y-intercept is at 5, 1, 2, 3, 4, 5 right here. And the slope is up 1, 1 to the right, or down 1, 1 to the left. And this is greater than equal to tells me it's a solid line, and greater than tells me that it shades above the line. There we go. Okay, once again, add x to both sides. I have x minus 2 greater than or equal to y. This is mean y is less than or equal to x minus 2. Y-intercept of negative 2. Slope is 1, so up 1, 1 to the right. But down 1, 1 to the left. It's less than or equal to. The equal to tells me it's a solid line. And less than means we're going to shade below. There we go. Let's move on to number 3. So number 3 said I had Ajad. Ajad. That's his name, Ajad. Ajad is selling sandwiches. The amount of cheese, y in pounds, left in the store is a linear function of time passed, which is x, since the time of the opening, which graph could correctly represent this linear function. So it looks like he started out with 4 pounds of cheese, and then what is this number here? That's 20. 1, 2, 3, 4, 5. 20 divided by 5 is 4, so that's got to be 4. 8, 8 plus 4, that's 12. 12 plus 4 is 16. There we go. So that means that he started out with 4 pounds of cheese, and then, what is that, 12 hours later, so this is, at the beginning, there's 4 pounds of cheese, and this means 12 hours later he ran out of cheese. And this bit down here, this doesn't make any sense, because it means now he has negative cheese. There's no negative cheese here. So in part B, there's no negative cheese, and then this is like time is negative. Well, there's no negative time. Time is right here. It's not like you go back in time and make more cheese, so that's no good. So looks like C is the right answer, because it starts out here at time 0, there's 4 pounds of cheese, and then 12 hours later there's no more pounds of cheese. So this is the correct answer, and then of course D, that part is incorrect. So in this case, we are referring to the domain of the domain is from 0 to 12 hours, and the range is from 0 to 4 pounds. So domain is 0 to 12, and the range is 0 to 4. With the others, it looks like it goes down to, like negative cheese. That's not going to happen. There's negative time, that doesn't happen. Okay, let's turn the page. Alright, consider this function and the function g of x, which is right here. So we want to compare the two functions. We want to write the function for g of x. Well, you can see that in g of x, it's increasing from 3 to 9. That's like, is that 6? Yeah, that's 6. And then is it another 6 this way? Yes. And then another 6, another 6. Okay. And then this here is a change of 2, change of 2, change of 2. So the slope is going to be 6 over 2 or 3. So g of x is equal to 3 times x, and then plus some number. Now, there are lots of different ways of doing it, but the easiest way is no, let's just plug in some values. We're going to use the 0.13. And then we're going to use the slope of 3. So in point slope form, it's going to be what's y minus 3 equal to 3 times x minus 1. So here's the 0.31. There's the slope of 3. So we have y minus 3 is equal to 3x minus 3. Add 3 to both sides. Y is equal to 3x. Oh, so there's our function. Looks like the y-intercept is 0. Okay, now part B. Compare the slopes of f of x and g of x. Okay, so f of x, the slope is right here, 4. And then for g of x, the slope is right here, that's 3. So f of x has a bigger slope. G of x has a smaller slope. Okay, when might the value of f of x be, g of x be the same? So we want to know when is f of x is equal to g of x. So we can take the function f of x, that's 4x minus 1, and we said equal to the value of g of x, which is 3x. So to solve for this, you can minus 3x to both sides, and then you have x minus 1 is equal to 0. So x minus 1 is equal to 0. You can add 1 to both sides, and you have x is equal to 1. So when are they going to be similar? When x is equal to 1. Because when x is 1, y is 3 on both of them. So 1, 3 is where the two lines intersect. Okay, part D. What are the x and the y-intercept for each of the functions? Okay, so f of x is equal to 4x minus 1, and then g of x is equal to 3x. So to find the y-intercept is easy. The y-intercept here is negative 1. The y-intercept here is 0. So y-intercept for this one is negative 1. The y-intercept over here is 0. Okay, so how do we find the x-intercept? Well, to find the x-intercept, we let the y equal to 0, and f of x is the same thing as y. So 0 is equal to 4x minus 1. You add 1 to both sides, you divide by 4. X is equal to 1 over 4. That's your x-intercept, is 1/4. To find the x-intercept for this part, we're going to let the y equal to 0, or y being g of x. So 0 is equal to 3x, so the x-intercept is equal to 0. So, for f of x, the x-intercept is 1/4, the y-intercept is negative 1. And for g of x, the x-intercept is 0, and the y-intercept is also 0. Okay, part E. Are g of x and f of x parallel, perpendicular, or neither? Now, f of x, we already know is 4x minus 1, and g of x is equal to 3x. So, if the slopes are the same, then it's parallel. If the slopes are perpendicular, then if the slopes are opposite reciprocal, then the lines would be perpendicular. But 4 and 3, the slopes, not the same and not opposite reciprocal. So they will intersect, but not in any particular way. So I'm going to say that it does intersect, but it's not parallel and it's not perpendicular. So the answer is neither. How do I know? Because it has different slope. And the slope is not opposite reciprocal. So they will intersect. There we go. Okay, part 5. Write the equation for the absolute value. So here is that absolute value. Look at the vertex, and then look at the slopes. The slope on this side is 1, the slope on this side is negative 1. So it looks like it's a translation of y is equal to the absolute value of x. And then it looks like it moves 1, 2, 3, 4, 5 units to the right. So it's y is equal to absolute value of x, 5 to the right. So it's going to be minus 5. It's opposite. And then it clicks 1 up. So there's your function. And then with this function, it's the same slope here, 1 here, negative 1 here. So it's going to be y is equal to absolute value of x. But it moves to the left, 1, 2, 3. So it's going to be plus 3. Yes, it's backwards. And then it goes down 3, so it's minus 3. And up and down, it's normal. And then for this function, it looks like the slope is still 1 and negative 1. So we still have y is equal to the absolute value of x. It moves 2 clocks to the left. So it's plus 2, and it clicks up 3. And there's your function. And then here's this function. Slope is still 1 and negative 1. So we have y is equal to absolute value of x. It looks like it moves over to the right 1, 2, 3, 4. So it's going to be minus 4. And then it goes down 1, 2, 3, 4, 5. So it's minus 5. So the inside tells you right or left, and it's backwards from what you think. And the number on the outside, it's moves up or down, and it's exactly what you think. So positive is up, and negative is down. Alright, number 6. An executive at Ben & Jerry's want to examine the relationship between the number of ice cream sales and ambient outdoor temperature. The scatter plot shows the relationship. Write an equation for the line of best fit. So I'm going to guess this. I'm going to just draw, how about this line right here? Looks like this line goes through a bunch of points. There's 1, 2, 3, 4, 5, 6 on top, 1, 2, 3, 4 at the bottom. It's close enough. I'm going to use this point. I'm going to use this point to come up with the equation. So that looks like 100. What is it? 110, 105. So maybe this is the point 104, and the y value looks like it's about 100. And then with this point, it looks like x is, what is that, about 90. And the y value, it looks like it's, you can read these things. I think that's 60, 40, 60, 80, no, 40, 20, 100, 80, 60, 40, okay, that's 60. There we go. So I have 2 points that I picked that's on the line, and I'm going to write an equation. First I have to find the slope. So the slope is a change of the y divided by the change of x. So it's 100 minus 60 divided by 104 minus 90. That's going to be 40 over 14. So 40 divided by 14 is not a nice number, but we can divide it. And looks like the slope is roughly 2.857. Let's round up to 2.9. No, let's round to 3. No, that's too much. We'll keep it at 2.9. Okay, so now we can write the equation. First I'm going to write it in point slope form. So point slope form is y minus y1 is equal to m times x minus x1. I already know the slope, that's 2.9. I need a point. I can use 104, 100, or 90, 60. I'm going to use 90, 60 because I like the smaller numbers. Okay, so it's going to be y minus the y, that's 60, equal to the slope, that's 2.9, and it's going to be x minus 90. So I want to put this in slope-intercept form, so it's going to be y minus 60 is equal to 2.9x minus 2.9 times 2.9 times 90. And that comes out to be 261. And then to get y by itself, I just add 60 to both sides. And I have y is equal to 2.9x minus 201. Okay, so what does this mean? It means that if the temperature is 0, the guy sells negative 201. Well, that doesn't make any sense. But it means you're not going to sell the ice cream when it's 0 degrees. So that's what the y-intercept means. The slope, 2.9, that means for every increase in temperature, every 1 degree change, you sell an extra 2.9 ice creams. 2.9 or 2.9, I'm not sure what this means. It could be thousands, could be millions, but it means an increase in 2.9 ice creams over 1 degree in temperature. Okay, let's move on. Part C. Okay, it looks like we don't do anything here. I think this one is about the piecewise function. Okay, don't worry about it. Number 8. Jimmy had noticed that the number of new growth palm tree sprouts that appear in the backyard each year follows the sequence 1, 4, 7, 10. Meaning 1 new sprouts in 0 year, 4 new sprouts in 1 year, 7 new sprouts in 2 years, and so on. So first year there's 1 sprout. Oh, 0 year, 1 sprout. And then the second year, what is that? The second year, No, then 1 year later, it's 4 sprouts. And then 7 years later, no. And then 2 years later, it's 7 sprouts. And then 3 years later, it's 10 sprouts. Is that right? Yes, it is. Okay, good. So we have to write an equation, and then we have to say how many sprouts after 20 years. So we can find the slope. So the slope, I'm going to use these two numbers. It's going to be 4 minus 1 divided by 1 minus 0. So it's 3 over 1, or 3. And that's your slope. That means every year there's 3 more sprouts. And the y-intercept is at 1. So the equation is y is equal to 3x plus 1. Or f of x is equal to 3x plus 1. That means at the beginning there's 1 sprouts, and every year it is increased by 3. And they want to know what happens in 20 years. So we're looking at f of 20. So f of 20 means how many sprouts will there be when it's 20 years. So it's going to be 3 times 20 plus 1, which is 60 plus 1, which is equal to 61. So 61 new sprouts in year 20. Okay, next. On Thursday, the Fantabulous Theater sold 175 balcony tickets, 475 orchestra tickets, and made a total of $11,600. The sum of the balcony tickets price and the balcony ticket price was $32. And then on a Saturday matinee performance, the Fantabulous Theater sold 132 balcony tickets and 201 orchestra tickets for a total of $5,604. Ticket costs same price for this concert as they did in the previous concert. So they want to know what is the price of a balcony ticket and the price of an orchestra ticket at the Fantabulous Theater. So we have 2 unknowns. We need 2 equations. So the first unknown is going to be B, which is cost of 1 balcony ticket. And then O, no, not O, let's go with R. R is cost of 1 orchestra ticket. So like I said earlier, we have 2 unknowns, we need 2 equations. The first equation is going to involve 175 balcony tickets, 475 orchestra tickets, total cost $11,000. So this is the cost equation. So they sold 175 balcony tickets. Each balcony ticket is B. That's the cost, that's the amount of tickets. And then the second equation is going to be 475 orchestra tickets times R, which is the cost of an orchestra ticket. That's how much money they sold in orchestra. That's how much money they sold in balcony. And it's a grand total of $11,600. The second equation says the sum of the balcony tickets price and the orchestra ticket price was 32. So B plus R is equal to 32. Now we can couple up with another equation involving this, but it's completely unnecessary because we already have 2 equations, and I like these 2 equations. So there's no need for a third equation. So we stop there. Now look at the way this is lined up. It's B with B, R with R, constant with constant, so we should write the elimination tickets. Now this is 175B, and I want this one to be negative 175B. So I'm going to multiply this by negative 175. Okay, so now the equation 1 is still 175B plus 475R is equal to 11,600. The new and improved second equation multiplied by negative 175, so negative 175B minus 175R is equal to 175 times 32, 175 times negative 32, that gives you negative 5,600. So now we can add the two equations together and the b would disappear. So 475r minus 175r is going to be 300r. And 11,600 minus 5,600 is going to be 6,000. So after we divide both sides by 300, then we can see that r is equal to 20. So the meaning of this is that it's $20 for orchestra tickets. So to find out the cost of the balcony tickets, we know that b plus r is equal to 32. Then r, we can substitute 20, so b plus 20 is equal to 32. So b has to be equal to 12. So the meaning of this is $12 for the balcony tickets. So $20 for orchestra, $12 for balcony. Alright, that was pretty quick. So let's do number 10. Carla is investigating two linear functions. The first linear function is defined by this equation. The second linear function passes through this point and this point. Not nice. That's a k, not a y. We need to find out what that is. So it says for the case when the two linear functions have the same y-intercept, what must be true for k? So if they have the same y-intercept, then maybe we should find out what the y-intercept is. So let's start with 4x plus 3y is equal to 12. We need to solve for y. So you know 3y is equal to minus 4x plus 12. Divide through by 3. And y is equal to negative 4 over 3x plus 4. So we know the y-intercept has to be 0, 4. Okay? So we got that from the first equation. And then the second equation, we know that it has negative 6 is 0, and it has the point negative 3k. So what can we do with this? We can look at the slope. So let's check out the slope. If you remember, it's y minus y, so it's k minus 0 divided by negative 3 minus negative 6. So this means negative 3 plus 6. So plus 6. So that means we have k over 3. Okay, so that's your slope. Now we could find the slope a different way. We know that one point is negative 6, 0, and we know that the y-intercept is 0, 4. So we use that as a point. And then when we look at the slope here, you know it's going to be 4 minus 0 divided by 0 minus negative 6. So that's going to be 0 over 6 or 2 over 3. So the slope, of course, is the same because it's the same line. So we got k over 3 is equal to 2 over 3. So of course k has to be 2. So there's your answer. It goes to the point negative 3, 2. Negative 3, 2. So there's your value of k. Okay, moving on. Alright, so number 11, it says system of linear equation is shown below. You know how to solve for this, don't you? Okay, now there's some writing in here. It says, Calvin is attempting to prove that replacing 3x minus y equals 8, that's the bottom equation, with a different equation, it will sometimes produce a new system of equation with the same solution. Calvin plans on multiplying this by 2 and then adding it to the top equation in order to create a new equation. So dude thinks that the new equation that he replaced is going to be this function. Is he correct? I don't really know. Why don't we just solve it and see what happens? So I see 2x, 3x, I'd like this to be negative 4. So if I multiply that by 4, that's going to really help a lot. So it's 2x plus 4y is equal to 10. And then multiplied by 4, you get 12x minus 4y is equal to 4 times 8, which is 32. So I multiply this by 4. So that's using, what is it called? Multiplication property of equality, which is totally legit. this equation is equivalent to this equation. They don't look the same, but they're essentially the same equation. So I can add an equation to another equation. That's called addition property of equality. So if I add the two, I have 14x. The y goes up here, it goes away, that's equal to 32. So x is equal to 32 divided by 14. So 32 divided by 14, that's going to be like 2.28 or whatever that is. That's my answer. And then I can solve for y. So the trick in solving for this is multiply the bottom equation by 4, right? I get this, and then I add this to the top equation, and I get this equation. Okay, and then I solve for x. Now, this guy, what is he saying? He's saying that he multiplied this equation by 2. So you multiply 3x minus y equal 8 by 2, then you get 6x minus 2y is equal to 16. And then adding the result, I'm going to add this to 2x plus 4y is equal to 10. So the new result is going to be 8x plus 2y is equal to 26. So he said that's what he gets. Oh, but that's not the same. He got 6y here. So I'm going to guess that he thinks that that's a plus 2y. And that's why he gets 6y. But essentially, is Calvin correct? The short answer is no. He made some errors on the way. And you can say the error is that he didn't add this correctly. But really, he should not have multiplied by 2. He should multiply by 4. He doesn't have to multiply by 4, but that's how we solve for it. So his idea is correct. You can multiply this by any number and add it to the top, and then it's still legit, except he screwed up on the error. Okay, so now number 12. Which of these are not functions? Vertical line test. That's a function. Vertical line test goes to only one. That's a function. Vertical line test goes to point. Not a function. This one goes to a whole bunch of points. Not a function. Alright. Number 13. The graph of f of x and g of x are shown on this coordinate plane. What the equation for the function of f of x? Maybe it should be what is the equation, maybe? And what is the equation for g of x? And what's the change of f of x to g of x? Alright, so let's talk about f of x. F of x is right here. It moves down 1, 2, 3, 4 from its original function. So f of x is going to be absolute value of x, and then it's minus 4 on the outside. What about g of x? Except g of x is 2 clicks to the right. So it's going to be x minus 2. Does it move to the right? Yeah, that's absolutely right. So that's f of x, there's g of x. And the change from f of x to g of x is that it goes up 4 units, and it goes to the right 2 units. So we say from f of x to g of x, it moves up 4, and it moves to the right 2. So how do we write g of x compared to f of x? We can say that g of x is equal to f of x. It moves 2 units to the right. So I'm going to say minus 2 in here. And then it moves up 4. So there is your g of x. Okay. Number 14. Explain the shift from function g of x is equal to f of x minus k. So we can say that g of x is f of x, but it moved k units. Now k units, the k is on the inside, so it goes either right or left. So assuming k is positive minus k, it's going to be k units to the right. Yes, it is. Because it's negative. Negative, which is to the left, in fact, is to the right. Okay, fine. So now g of x is f of x minus m. The m is on the outside. So we say g of x is f of x, move m unit down, assuming m is a positive number. And then finally, it's plus r and it's plus d. So it's going to move b unit to the left and d unit up. So we say g of x is f of x, move r unit, it's positive, so it's going to be to the left. And then d unit, it's positive, so it's up. So up d and r to the left. And that concludes the review for Chapter 2 exam, Unit 2 exam. So Chapter 3, 4, and 5. So you were supposed to take this exam online, and that's a one-shot deal. So if you want to redo, you're gonna have to do it on paper. So study this, and then take your test again. Okay, I'm done. Bye-bye.